In the grand, predictable dance of the cosmos, we think we know the rules. Gravity holds things together. Stars are born and they die. And black holes, for all their mystique, are supposed to follow a certain logic. They start small, born from a collapsed star, and grow patiently over billions of years. These are the foundations of our cosmic understanding. But what if something out there broke those rules? Something so big, so bright, and so ancient that it just shouldn't exist? Way out in the infinite universe, a monster is hiding in plain sight. It's a black hole packing the mass of tens of billions of suns, shining with the fury of 100 trillion. It's called TON 618, and it's a beautiful, terrifying problem that threatens to break our understanding of the universe. A monster in disguise. Our story begins not with a cosmic bang, but with a quiet observation. Back in 1957, astronomers at the Tonantzintla Observatory in Mexico were cataloging faint blue stars. Among them was entry number 618, noted for its purplish hue, but otherwise dismissed as just another star. For over a decade, that's all it was. A curiosity filed away. The universe, it seems, is a master of secrets. The first hint that something was wrong came in 1970 when an Italian radio survey picked up powerful radio waves coming from TON 618's location. Stars don't do that. This wasn't a star at all. Follow-up studies confirmed it. TON 618 was a quasar, a quasi-stellar radio source. Specifically, it's a radio-loud, broad-absorption line quasar, which is a mouthful that means it's incredibly energetic. We were looking at the blazing heart of a distant galaxy, powered by a supermassive black hole. But it was the distance that really blew the case wide open. By analyzing its redshift, how much its light has been stretched by the expanding universe, astronomers figured out that its light had traveled for a jaw-dropping 10.8 billion years to reach us. This means we're seeing TON 618, as it was when the universe was just about 3 billion years old, a mere toddler in cosmic terms. And this is where it gets weird. The data from this ancient beacon was unbelievable. Its brightness was clocked at 140 trillion times that of our sun, making it one of the most luminous objects ever found. This led to a mind-bending calculation of its mass. Early estimates based on the motion of gas swirling around it placed the black hole at a staggering 66 billion times the mass of our sun. To put that in perspective, the black hole at the center of our own Milky Way, Sagittarius A star, is about 4.3 million solar masses. TON 618 is over 15,000 times more massive. More recent measurements from 2019 using a different method have suggested a more conservative, but still monstrous, mass of around 40.7 billion suns. Whether it's 40 or 66 billion, this thing is so massive, it outweighs all the stars in our Milky Way galaxy combined. It's a new class of object, an ultramassive black hole. Its physical size is just as hard to wrap your head around. The event horizon, the point of no return, would stretch nearly 400 billion kilometers across. If you plopped it into the middle of our solar system, it wouldn't just swallow the Earth. It would swallow every single planet, reaching 40 times past the orbit of Neptune. Our entire solar system would be a tiny, insignificant speck. This all led to the one question that keeps astrophysicists up at night. How did something get so ridiculously big, so early in the universe's history? The timeline just doesn't work. The rules, as we knew them, were officially broken. The rules of creation. So, why is TON 618 such an anomaly? First, we need to talk about what's considered normal. In the standard model, black holes come in two main flavors. You have your stellar mass black holes, the common variety. They form when a huge star, at least 20 times bigger than our sun, dies in a supernova explosion. The core collapses, and you're left with a black hole a few dozen times the sun's mass. From there, they can grow by sipping on gas or merging with other stars. It's a slow and steady process. Then you have the supermassive black holes, the titans that sit at the center of most big galaxies. These guys weigh millions to a few billion times the mass of the sun, but they didn't get that way instantly. The leading theory is that they start as smaller seed black holes and grow over cosmic history by gobbling up gas and dust, and more importantly, by merging with other black holes when galaxies collide. Think of it like a snowball rolling down a very, very long hill. It starts small and gets bigger over 13 billion years, with the snow being stars, gas, and other black holes. Both of these growth plans are held in check by something called the Eddington limit. A black hole can't just eat uncontrollably. As gas and dust fall in, they form a super hot spinning record of matter called an accretion disk. This disk gets so incredibly bright that the light it blasts outwards physically pushes back against more stuff trying to fall in. It's a natural safety valve. The more it eats, the more radiation it produces, which slows down its eating. It's a cosmic speed limit for consumption. And this is where TON 618 floors the accelerator and plows right through the guardrail. The anomaly. The problem is simply time. We're seeing TON 618 when the universe was only 3 billion years old. According to our models, even if a black hole started growing right after the Big Bang and ate at the absolute maximum speed allowed by the Eddington limit, there just wasn't enough time for it to reach 40, let alone 66, billion solar masses. The math doesn't add up. It's like finding a fully grown 300-foot-tall redwood tree that's only 3 years old. It's a temporal impossibility. This object grew faster than our laws of physics say it should have. It breaks the very mechanism designed to keep its growth in check. This isn't just an outlier. It's a paradox that challenges our core understanding of how the universe builds things. So, what gives? The key is its identity as a quasar. When we look at TON 618, we aren't seeing the black hole itself. That's impossible. We're seeing the blindingly bright death scream of all the matter it's currently devouring. The sheer friction in its accretion disk heats matter to unimaginable temperatures, causing it to shine with the light of 140 trillion suns. This light is so intense that it completely drowns out its entire host galaxy, which remains invisible, lost in the glare. This extreme brightness is a direct measurement of how fast it's eating, and the rate is simply furious. This forces us to consider some pretty extraordinary possibilities for how it got here. Investigating the how, a cosmic whodunit. If TON 618 couldn't have grown the normal way, we have to explore ideas on the fringes of theoretical physics. There are 3 main suspects in this cosmic whodunit. First up, a privileged birth. Maybe TON 618 didn't start from a dead star. The direct collapse model theorizes that in the very early universe, giant clouds of primordial gas, hundreds of thousands of times the sun's mass, could have collapsed directly into a black hole, skipping the star phase entirely. This would have given it a massive head start, creating a heavy seed that was a monster from day one. It'd still need to grow, but starting at 100,000 solar masses is a lot easier than starting at 30. The second suspect is a life of crime, a process called super Eddington accretion. This theory suggests that under certain conditions, a black hole can break the cosmic speed limit. If matter falls in clumpy streams instead of a smooth flow, the radiation might not be able to push back effectively, allowing the black hole to gorge itself at a runaway rate. For TON 618 to get this big, it would have needed to maintain this binge eating for a very long time, which is tricky to explain, but not impossible. The third, most chaotic explanation is a frenzy of mergers. The early universe was a cosmic mosh pit, with galaxies constantly crashing into each other. It's possible TON 618 is the result of a rapid chain of black hole mergers. Picture a young galaxy with a heavy seed black hole that merges with another and another and another. Each time, their central black holes combine and grow. To reach its current size, this would have required a perfect storm of cosmic collisions, all happening at just the right time. Each of these ideas pushes our models to the breaking point. The truth might even be a combination of all 3. A heavy seed, born from direct collapse, that then binged on gas while fueled by a chaotic series of galactic mergers. A beacon in the dark. While TON 618 is a huge paradox, it's also an incredible scientific tool. Its insane brightness acts like a cosmic lighthouse, shining a beam across 10.8 billion years of space-time. As that light travels to us, it passes through invisible clouds of intergalactic gas. These clouds leave a barcode-like fingerprint in the quasar's light, known as the Lyman Alpha Forest. This allows astronomers to map the invisible cosmic web, the vast filamentary structure of matter that connects galaxies. And in 2021, observations with the ALMA telescope revealed something stunning. TON 618 and its hidden galaxy are sitting inside a gigantic nebula of glowing gas, known as a Lyman Alpha blob. This cloud is colossal, measuring over 330,000 light-years across, more than twice the diameter of our entire Milky Way galaxy. The whole thing is being lit up, made to glow, by the intense radiation blasting out of the quasar. This shows that these ultramassive black holes aren't just sitting there. They are active architects of their environment. The energy pouring from the quasar can blow away gas and shut down star formation, or compress it to trigger new bursts of star birth across its entire galaxy. TON 618 isn't just a mystery, it's a living laboratory for understanding how galaxies and their central monsters grow up together. So, we're left with a cosmic paradox. An object that's too big, too bright, and grew up way too fast to fit our theories. TON 618 is a monument to the universe's ability to create extremes that dwarf our imagination. This is a very active field of research, and the story is constantly evolving. Recent studies and simulations are exploring how rule-breaking black holes in the early universe might have undergone periods of extremely rapid growth, challenging our assumptions about how accretion disks work. It suggests the rules that govern black holes today might not have been the same rules that applied in the universe's chaotic youth. TON 618 isn't just an astronomical oddity. It's a signpost pointing toward a deeper understanding of physics we have yet to uncover. It's a humbling reminder that for all we know, the universe is still full of monsters in the dark, and we've only just started to find them. What's your theory on TON 618's impossible growth? Let us know your thoughts in the comments below. If you enjoyed this cosmic mystery, like the video and subscribe for more stories about the darkest secrets of the universe.